Let's look at some plotting features of MATLAB. Let's talk about line plots. The first command, x equal to this command, creates a line vector starting at 0 and ending at 3 pi with step size equal to pi by 100. So y equal to sine x produces sine of each of the entries of the x vector, and then plot xy returns the plot of this data. So the plot, since I have taken sine function, plot xy plots the sine function at the value of x vector. So this plot is a raw plot, it's not conditioned yet. So we can improve the plot by using some further commands. Axis tight puts the entire plot in a tight box. Previously, it was sort of hanging loose. The area, the plot box, is not chosen to fit the plot completely. So this part is hanging loose as is visible. So axis tight puts the whole plot in a tight box. And then grid on turns on the grid so that the visibility and data analysis is easier with the grid on. The axis may be labeled. The labeling may be done by using the X label and Y label commands. For the three-dimensional plot, we have Z label also. So here we talk about two-dimensional plots only. So X label takes a string, and whatever is in the string sits on the x-axis. It labels the x-axis as shown here. Y label likewise takes the string and plants it along the y-axis with orientation along the y-axis, as it is happening here. If I look at the dots plot, previous plot was a line plot. If I say plot xy and prescribe a format for the data, r dot, means I have asked for red colored dots for the x and y vectors. So that's what we see here. By default, MATLAB interpolates between the points. So the previous plot, in addition to the data, which is points, MATLAB has interpolated with a line. Since the format here is a dot, so there is no interpolation. So we can see just the data and the points of the data. Axis tight and grid on puts the entire plot in a tight box, and grid on turns, of course, the grid on. The command text allows me to plant specific strings at some coordinate locations. So the text command at 5 and 0.2 coordinates, 5 and 0.2 coordinates, the string that I have placed at these coordinates is text, T-E-X-T, so which is highlighted here in this ellipse. So this is where the text is planted by using the text command. So gtext is a command which allows us to make the choice. Instead of giving the coordinates, gtext provides this crosshair. So this crosshair can be moved over the whole area of the plot, and wherever the mouse click is made, at that location, the string, which is argument to the gtext, sits. Here, I said the argument is gtext crosshair, and I have chosen the point shown by the crosshair. At that location, gtext crosshair is a string which sits at that location, and it's gtext is the command to be used for texting the plots by using crosshairs. So here we see many properties of the plot, how different properties may be controlled. So x is a vector going from minus pi to pi with steps of pi by 10, and the function we are plotting is tan sine x minus sine tan x. So several properties of the plot are set here in single command. So the line type format is a dashed line, M for magenta. So the dashed line is plotted and the color of the line is magenta. S stands for square, the marker size. This is the marker. A marker shape is a square. The line width is 2. So this is the line, the dotted line here. The line width parameter is set to 2. Marker edge color, squares are the shapes chosen for the marker. Its edge color is taken as K. K is black. So the edge color is black. The face color for the marker is yellow. So whatever is filled inside the tiny squares is yellow color. That property is called marker face color. And the marker size is 10. So for marker size set to 10, these are the sizes of the square boxes which appear. So these are the locations where the data occurs. The magenta line is interpolation, and this is how the whole plot is formatted by using these commands and these parameters. So the marker face color property is here, marker edge color property is here. The double dash, the dashed line magenta is the property which describes the interpolated line, and the line width parameter is the one which applies to the thickness of the dotted dashed line. The marker size parameter, if you look at the two commands, in the previous command I have used marker size as 10, which is shown here, and when I change the marker size to 20, the marker shape, which is square, is now increased to 20 marker size. So the squares have become much larger and the other parameters are the same. So this is how the various properties of the plot may be set. More on MATLAB plots to come in the next video. Now let's look at the properties values, that is the various properties which may be set in the MATLAB plots. The color may be controlled, the style of the data may be controlled, and the line style of the lines may be controlled. So the color, you have these options: blue, green, red, cyan, magenta, yellow, black, and white. The data, when it's plotted as dots, we have the following options: point, circle, X mark, plus marks, star, square, diamond, triangle down, triangle up, triangle left, triangle right, pentagram, and hexagram. And if line is chosen, then you have solid lines, dotted lines, dot and dash lines, dashed lines, or no line. So these are the various properties which may be set with the plot command, and the plots could be accordingly drawn.